Yes, sir, thank you. Evening is a time of real experimentation. You never want to look the same way. Good evening, everyone. This is Asha, Department of English. It's my pleasure to invite you all to the today's faculty development program. Yes, it's time to welcome you all. Good evening to everyone over here. A warm welcome to all of you to the faculty development program. I'm overwhelmed to welcome our chief guest, Dr. P. Krishnamoorthy, Assistant Professor, Department of Computer Science, Chennai. I also welcome our principal, Dr. V. Nagachodi sir, Vice Principal, Dr. N. Sujata ma'am, and my dear colleagues and my dear students and all the participants. It's a pleasure for me to welcome all the delegates of the FTB from all over the Tamil Nadu. Your presence is highly appreciable by all of us. I welcome all the participants in different categories who are excited to grab his ideas and views on the topic of discussions. Once again, I welcome you all. It's my immense pleasure to welcome Dr. V. Nagachodi, Principal of SCPJC, to present the presidential address to the participants. Welcome you, sir.
Thank you. Thank you very
Over
much.
to you, sir.
Very good evening to one and all. I'm extremely happy in inaugurating this data mining and machine learning workshop by Dr. P. Krishnamooorthy. And I also congratulate the efforts taken by Professor A.P. Babu, head of the Department of Computer Applications, and Dr. S. Ravichandran, head of the Department of PG Department of Computer Science. And it also gives immense pleasure to me in inviting Dr. P. Krishnamooorthy sir, who's a close friend of mine from the Tamil Nadu College, to address our audience today on data mining and machine learning as a faculty development program. And this is a 7 days program, and today is the second day of the MDP. And let me also express my sincere thanks to our Honorable President, Mr. Negi Chandji, and as well as to our Honorable Secretary, Sir, Mr. Ravi Kumar O. Jain ji. We know both of them, they have given constant encouragement to all of us, and they were instrumental in organizing this faculty development program, particularly on the recent trends in computer science. Whenever we discuss about data mining, it is a method of extracting data from multiple sources and organizing this data to derive valuable insights. And there are large number of companies, they cannot live today without this data mining because they have to evolve and keep up with the technology evolution, the upcoming digital trends to stay ahead of the competition. So business today are prioritizing and staying abreast of all the new developments in the field of data science and the data analytics. Data mining is one such process in data science, and it involves an examination of pre-existing data sets to gain new and useful information. The complex data mining algorithms allow companies to make sense of raw data by segmenting large data sets, identifying patterns, and predicting outcomes. So today, know that the data mining is having wider applications, particularly in terrorism, counter-terrorism, then manufacturing engineering, then criminal investigation, then biological data analysis, then the energy industry, then higher education. We are widely using these data mining applications are here. Then retail industry, then intrusion detection, then telecommunication industry. You know the 5G telecom is on the arrival of probably by next year. We are going to have a 5G network in India. So at that time, no, definitely this data mining will be very useful to us and financial analysis. So most of you are now coming from commerce background, they are here. And those who are really wanted to be an expert in commerce field. So this data mining in financial analysis will be very good. I'm also thankful to all our faculty members, and including our vice principal ma'am and Mr. Balaji sir, who is behind the backbone of this senior link, and as well as AP Babu sir, and all my dear colleagues and their students. So in these few words, I hope that all of you are going to enrich your knowledge in data mining and machine learning So with these few words, I'll hand over back this session to Asha Devi ma'am for further comments. Thank you so much. Have a nice evening.
Thank you, sir. It's time to introduce our chief guest to the participants. I would like to request Dr. Ravichandran, Assistant Professor and HOD, Department of Computer Science in PG, to give a chief guest introduction to the participants. Welcome, sir.
Welcome, ma'am. Respected principal, respected chief guest, respected vice principal, and all HODs, faculty members, and all participants and all participants. First, good evening to all. Today time is chief guest introduction. Today FDP program chief guest is Dr. P. Krishnamooorthy, MSc, MPhil, PhD. Then he is completed BSc Computer Science, completed at Bharatiyar University, Erode Arts College, 2000 completed. Then MSc Computer Science, he has completed Bharatiyar University, Nehru Memorial College, 2003, and MPhil also completed Periyar University, 2008. Last finally PhD completed. He has completed in PhD Wales University at 2020. Then Dr. Krishnamooorthy sir is the total 13 years experiences for various colleges in designation for resource person and assistant professors position. He has experience in 13 years experience. The area of specialization of Dr. Krishnamooorthy sir is multimedia system, object-oriented analysis and design, software engineering, system software, data mining, and artificial intelligence. Then area of also research about this latest technology of computer topics, IoT, Internet of Things, cloud computing, big data, that one. He has a book published in computer organization subject, and he had a paper publication in 3 Scopus international journals and some papers in local journals. Then welcome, sir. Once again, welcome. Today topic of data mining and machine learning part. Very good topic in computer science department. All BSc computer science, MSc, MCA, also participants. Thank you, sir. Once again, welcome to Krishnamooorthy, sir. Thank you.
Thank you, sir.
Thank you for
sir.
this.
Thank you, sir. A great welcome for
Thank you, sir.
all the faculty members, and I would like to thank to our Dr. V. Nagajodi sir for giving me the opportunity to deliver the address for a special topic in data mining and machine learning, the faculty development program. And also I'll thank to our head of the department, Dr. S. Ravichandran, and various faculty members in the department of UG, BSc and BCA department. I thank to everyone for the warm welcome and the great pleasure to present this topic. And this is also useful for the student community also, so and the faculty also. So the recent trends in the topic is selected for the FDP is a very good one. The SCJP Jain College is conducting such a wonderful FDP program. So I once again thank to Dr. V. Nagajodi sir, Principal, SCJP College. So now, ma'am, now I move on the presentation, ma'am.
Yes, sir. I have to inform our participant. Shall I?
Can I move, ma'am?
Before one sec, sir. I'll inform to our participants for the information. Before we move to the session, I request all the participants who can post your queries, if any, in the chat box. I feel honored to welcome our chief guest to take over the session. Now, the session is yours, sir. You can take over.
See, today we are going to discuss about this. These are the topic, the main agenda. So, machine learning and artificial intelligence. That means data mining concepts will become oh, covered in this topic, and also machine learning, type of machine learning, and then research. See, before that, data mining is a uh, data mining is a process of finding potentially useful patterns from huge data sets. It is a multidisciplinary skill that uses machine learning. See, in the machine learning, statistics and AI and other techniques to extract information and evaluate futures events probabilities. And data mining is all about discovering hidden and unsuspected and previously unknown a valid relationship among the data. And also it's called as a knowledge discovery data. So this that means extraction of the data or pattern analysis or information harvesting, etc. See, in data mining process is commended to the artificial intelligence. Artificial intelligence uh, are covered with the machine learning techniques. See, the artificial intelligence in the screen is a natural and man-made hand. That is a robotics. AI is the robotic hands and then natural hands. It's an example. In the artificial and intelligence, the two words are segregated here. How it has uh, become an new one to provide such a beautiful thing in a human. So it is related to making or manufacturing or producing machines. See, artificial mean as how does the process will become. That mean making to new one. See, making or manufacturing or producing the machines. And the intelligence means in the ability to learn, think, decide, and solve the problems. How the problem we are going to solve. That means we learn and think and decide, and the problem will overcome. See, this is the terms will be segregated: artificial and intelligence. See, the father of artificial intelligence, John McCarthy, is worldwide recognized as the father of John McCarthy. In the 1950s, coined the term as artificial intelligence. Before that, it is not termed, but 1950s the term is specified. And the AI is defined science and engineering of making intelligent machines. That means machines are previously not become intelligence. See, in the 1950s, after that, the machines will become put on more effort. It will become thinking, and that not a thinking. It is specifying that better one to provide uh, efficient performance and efficient results and execution more and more. See, in the screen will have a difference for that natural and artificial differences. The two screens are we have see the seesaw here also. You have left and right sides. We have natural as well as the artificial. See, artificials we are made it. See how we are made it in the natural. Defaultly you have the sufficient things and everything is we have, but in artificial, whatever we required, what kind of format we required, those things are we are implemented in natural. See, in the normal seashore, both sides we have. See, in the resorts and then various amenities we are provided, whatever we required, how the things we need, those things are we are adapted in this artificials. In the natural, that thing is that we have but limited, but in artificial whatever kind of things we need, all those things are we can easily adapt it. That model will become a better, more efficient. Artificial intelligence is a way of making systems and then systematic process, or it may be a program, think intelligently. See, this is similarly human thinking. Human thinking is one of the most powerful. See, we can calculate within a fraction of second number of values, or it may be remember 10 years data. Those things are we can easily able to fetch it in our mind. Like that, AI is also is a systematic process, as it will act as an intelligent human as being. And also AI makes a computer machine to learn, think, decide by itself. See, to solve this problem. See, for example, the machines read the data and process the data, and then automatically all the things it will reflect. That means the data will be transforming what kind of data we need, wherever we need. So those things are automatically think it the machine and solve it automatically. So that is we are going to decide it in AI. The ability to learn. See, the learning process in we are going to put it in a machine. So the ability to solve the problem, how it will be solved. See, the machine will learn and then solve the problem. Before that, what kind of problem previously we have, those things we are going to provide it. See, for example, this is for we can't able to draw an image. See, this the way we can easily able to draw the image. See, here an elephant, here an giraffe. See, those and images we can easily able to draw. See, how to solve this problem, we can think creatively. That creative thinking will we are going to implement in a machine. Then it will become an or AI is a powerful one. See, the timeline of artificial intelligence. See, in the 1950s is coined as artificial intelligence. The term is specified as see 1955. After that, it will John McCarthy to describe the science and engineering of the making intelligent machines, and that means 1955. After that, 1961, it will upgraded. Goes to work at GM, replacing the human on the assembly line. That is, a machine level instructions will be implemented. See, after that, COBOL programming also started. So, assembly language program is implemented. After that, developing MIT hold a conversation with human. See, after that, 1966, first electronic person from Stanford Shaky in a general purpose mobile robotic group that reason about own actions. After that, changing in 1997, Deep Blue, that is a chess playing. That means it will provide automatic gaming techniques also implemented in 1998. That some process will skip. And in 1998, introduce robotic, that is insofar detecting and responding people feelings, that robots will be created. After that, 1999, artificial intelligence robot with some skills will be developed. After that, 2002, Romoma is a vacuum cleaner will be introduced, automatic. See, after that, 2011, in the between gap, so around 8 years to 9 years, Apple integrates Siri and intelligent virtual assistant voice interface. We can easily recognize the voice. And in 2011, the same IBM also, at the same time, Apple and also IBM also introduced robotic, that is AI is introduced. In 2014, chatbot process Turing testing will be implemented, that is recognizing voice and images also. The same, Amazon also launches Alexa, an intelligent virtual assistant with a voice interface that completes shopping task. That means online shopping will be introduced in 2014. See, whatever the man required, all those things are recognized. In 2016, see, image recognitions, that is Microsoft chatbot toy goes rogue on social media, making more effective and image processing, also image recognitions, all the things will be introduced. In 2017, Google's AlphaGo Google's is introduced one new techniques. AI is introduced. The real person will become an all the activities. It's like a same similar human being, human thinking, human what kind of thoughts will deliver, speak, and everything, actions, all the things will available in 2017. Those things these are the timeline for AI. The next one is applications in AI. So various places we are using in AI: manufacturing robots, autonomous delivery robot, smart assistants, diagnostic assistants, proactive healthcare management, disease mapping, automated financial investing, and virtual travel booking agent, social media monitoring, inter-team chat tool, conversational marketing board, and natural processing language also. See, these are the more and more is available in AI. These are some listed. Here I am given. See, manufacturing robots is we can't able to work that place within 24 hours. We can't able to survive in hills area. We can't able to mining places. That particular places, manufacturing places, we use the robotic, automatic delivery. So delivery places also we can use an robotic system, smart assistants, wherever we required 24/7 without man. So that places also diagnostic centers. We can't able to move in our human body. So in brain, that particular place also we use the robotic systems, and also healthcare management system. There is sensing systems also using disease mapping. So these are the things we are used in AI applications. See, these are commended to machine learning. See, in machine learning, in machine learning, we are we are not going to think about how the machine will work. See, we are going to put how the machine going to think and how the machine will work and how the machine will deliver the results. That thing is we are going to uh, provide in the machine. See here, AI in machine learning is a paradigm. Here I'm given. See in this slide, in the AI is outer view, that is outer region of the AI, ability to sense, reasons, engage, and learn. See, in the AI is those things we covered in the natural language process. Before that, I told various applications. All the applications are have in machine learning, that is AI. In the machine learning, ability to learn, how the machine will going to learn. See, various specifications, that is supervised, unsupervised, and reinforcement learning. See, the three things we are going to apply for the machine learning process. And then, so various these three things, the three learning techniques, how we are going to implement machine learning technique. See, various techniques, that is various methods we have. See, some of methods here listed out: the regression, decision tree, and then naive bias, and then clustering techniques. Various things we have to implement all the machine learning ability to learn techniques, that is supervised, unsupervised, and reinforcement learning. So the technologies are enabling which platform, that is which operating systems, all the things, platform, various kind of platforms, Windows and Unix and all other operating system at the same time, different kind of programming interfaces, that are sensors and other physical enablement is required to implement in the machine learning technique. See, in the machine learning, uh, in the 19th century, so it will started. Machine can they be as intelligent as human, but so in the initially in the computers invented at the time, as the calculation processes will take 2 to 3 days. Not thinking the machine, but now all the thing is possible in motion. How it is named? It will we are implementing. The thing is how it will be remodify, how the algorithm, how the process, all the things will be possible. That means here machine learning is the field of study that give computer the ability to learn without being explicitly programmed. We are not programmed. So whatever the data we are provide, the data will be recognized and then process it. This is initiated in 1959. See here, uh, in the 19th century, so coined, that is 1950s coined as AI. See, in the 1990, what is the intelligent thinking was be implemented? See, in the 1992 till we are implemented machine learning techniques. Now the deep learning technique also we are going on. See, we are using now the deep learning technique is implemented. How the human is thinking, the same thinking will be implemented in machine. So that is we are going to provide in machine learning technique. See, the learning process is uh, various representations. His machine learning histories is previously AI histories we have started. Here, machine learning history in the 1950s, that is AI is implemented. See, at the time as machine learning was specified, that's it. After that, first natural 1960 meta line is implemented. After that, backpropagation 1970 neural network is created, and in 1980 AI is separate. AI is separated, and then boosting algorithm and reduce some bias, and then after the 2000 onwards, we are using we are transforming the AI as well as machine learning techniques. See, we move on deep learning techniques, we are analyze it. See, now in 2017 machine learning models are more and more we are started, and then now we are implemented well financed startup leverages in machine learning. Now everywhere we are implemented in scientific frontier in machine learning history. See, now this is the uh, various software industries developed in machine learning process in 1943. Neural network is sorry, can you able to see, can you
Please go
able to
ahead,
see,
sir. Please go ahead. No issues. Please go ahead.
sir? Can you able to see the screen, sir?
Yes, sir. Yes, sir. Please go ahead. First
Updated
screen is
screen, updated screen, can you able to see, sir?
no. Only first screen is there. Data mining in machine learning.
That first slide only is showing, sir.
First screen only is there.
Oh, sorry. Now it's
No, it's not moving, sir.
now it is
Unstream is there. No, sir, it is not visible.
Wait.
Yeah, it is visible, sir.
Okay, sir.
1943, 1952, 1956,
Yes, sir.
1950, 1959, 1989, up to 1989, it is
Okay,
visible.
sir. Now it is visible now?
Yes, sir.
Okay. In 1943, neural networks and algorithms we are started. Various companies are started. In 1952, IBM has introduced program that is playing programs. And 1956, FICO was founded. Predictive analytics to create credit score systems. That is a business process we introduced in the COBOL program also. That time is introduced. In the 1958, the programming thing is we are transforming. That is the same company has introduced business oriented applications. That is the machine learning process is 1959 at the time is started. After that k nearest neighbor algorithm was the first applied in the classification algorithm. So after that various process started in 1986, 89, 96, and 2006 and 2009. The database also more and more data is we are retrieved. The original data we are retrieved in 2011. So IBM Watson is used machine learning with natural language processing to beat human geopardy. And also Google also used the same. And in 2014, Facebook developed deep learning technique, that is a facial recognition system. And then 2016, Google Alpha, that is Google AI is introduced. And then 2020, now we are using machine learning techniques more and more. See, in the machine learning technique, computer program in the forming is the expression is here forming it experience E as experience with respect to sum of class, that is a task experience task, and the performance measure is P. This is the performance at task in T as measured by P improves with the experience. A computer program is said to learn from experience with respect to some class of task here and some measure P. If it is performance at a task in T, we are giving the task. We are going to give the task and machine. Previously, a computer program, we are going to learn. We get some experience and some class of task we are performed. We get some performance measure. Now we are going to assign the task in machine and measure the output of the value and improve the experience in machine, how the machine will work. This the thing is in machine learning. The Tom and Michael, the Carnegie Mellon University in 1997, he is just specified in machine learning. Type of machine learning. See here in the next slide we are going. Machine learning types. See previously the layered structure is shown in the slide. I think so in the machine learning AI with the machine learning process. There are specified supervised learning, unsupervised learning, and reinforcement learning. See, in the supervised learning, we have two categorization, classification and regression. And then unsupervised learning, clustering technique, and then reinforcement learning, decision making. See, in the classification, various type of algorithms we have at Navy bias, decision support tree, support vector machines, random forest, k nearest neighbors, and regression, linear regression, natural neural networks regression, support vector regression, decision tree regression, lasso regression, ridge regression, and then clustering, k-means clustering, and DB scans clustering, agglomerative hierarchical clustering, and Gaussian mixed clustering, and in decision making, Q learning, O learning, and tree learning. These are the algorithms we are going to use in various kind of learning techniques, that is supervised, unsupervised, and reinforcement learning. In the machine learning, the three learning techniques, first one is supervised. We are going to predict the next value. We can easily able to predict that value. So that is task driven now. So what the output will become, the thing is we are defined in the initial itself. See, we want like this kind of results we need. So that is supervised learning. That is a structure oriented. See, the next one is uh, not structure oriented, unsupervised learning. So data, we have collection of data. We are going to classify it, we are going to categorize it, we are going to find it out the results, which thing is we have, we are going to implement categorizations. That is clustering techniques is useful for in unsupervised learning. And next one is reinforcement learning. See, we are going to find out the problem where it is maybe partial output we have. That is there's a reinforcement is we are going to say semi-structured. See, we have some structured data, we are not having some unstructured data. See, the reinforcement is we are going to reformulate, and then we can implement what kind of thing processes we are going to specify in that. Third one is a semi-structured, semi-supervised. The first one is we are going to discuss about supervised learning. The supervised learning as a machine has taught all the things. See, we are going to implement known data sets. Whatever the input we are going to give, the expected output, we know that the algorithm must find the method to determine how right those are input and output process. See, the structure, the streaming process we can know very well. See, while the operator know the correct answer to the problem, the algorithm identify the patterns in data, learning the observation, and make predictions. This the results only will come. See, the algorithm will the structure we immediately respond for us. This is for supervised learning process. Say classification, regression, and focusing techniques in the supervised learning process. We have it. So accuracy level and then performance levels and regression level, recall level, F measure and K measure values. We have it. See, in the classification process, input raw data, and then these are the data we are given. See, in the process, algorithms we are provided in the algorithms. See, we are specified. See what kind of output we required. So the process logic we are implemented. The data will be transformed and perform the algorithm process, and then we can retrieve it in the output. We categorize what kind of data we are going to segregate it. That is A, B, C, like that. So red, green, and violet. So the conditions we are going to specify it. See, in supervised learning process, we are specifying splitted up the data in trained data and test data. We are categorized. Trained data will become a necessary that we need whatever kind of record data, noisy data, all those things are we are remove it when it means we are going to train mean. So at the time the train data set will be we can receive it. the noisy data and other unused unwanted data and some missed data, we are split it out in 30% maximum. We reduce it. 100 data we can take it. So some data that is if we are make it a 10-fold splitting or 15-fold, 5-fold, minimum 5-fold splitting we are implemented in maybe various tools, maybe and research tools we are going to use at the time. In the supervised learning, automatically split it out the trained data sets, we can easily able to retrieve it. In the image classifications, in this box, we have two more images we have. See, is this a cat or a dog? See here, in the black is, I think so, dog. In the brown is, I think so, cat. So this is one is maybe the images may be both of the images may be cat or it may be dog. See here, the input layer we are specified. Okay, so and then activation neuron, that is a neural network techniques here used, and then we can receive it either anyone only. We can receive it. Maybe an image classification. It may be any only one. It may be a cat or it may be a dog. So the two option only we have it. So number of input we have. So the number of input layer, the hidden layer perform various neuron, and then we can finally get it the only one results. In the supervised learning, the three things we are specified: classification, regression, and forecasting. So the first one, as I said, classification. The prediction is based on the input and the process and output. We can know exactly. The machine learn program must draw the conclusion from the observed values and determine to what category new observation belong. That is what we are giving the input. So so this is the output we are going to receive. So that is available in classification. Okay, so for example, we are receiving a mail, so spam mail or it not spam, we use this filter. We can easily able to filter it the messages. Okay, so the next one is regression. The machine learning program must estimate and understand the relationship between the different variables. See, whatever the variables we are provided, that is required or not required. See, that is regression techniques we use it. So we can, if that value will be neither means, we can use it. We can find the results easily. So it is changes in that value, maybe changes in particular prediction, or it may be results. That means the next example we'll solve that. Then the forecasting, the prediction about tomorrow and day after tomorrow, whatever the results we can get it in the sky and weather. So various places, those things we can use previous data segments. We can use it in supervised learning techniques. See, this is for unsupervised learning. This is the image. We have more data. We have more data. See here, machine learning algorithm studies identified patterns. Here we can't able to where it is the pillows or where it is the images, where it is the toys. The child is identifying the images. See, there is no answer key. That means here we can't able to find it immediately. So what we are going to do, see, we are going to relate one another. See, we are going to correlate and relationship analyzing available data. Okay, so then only we can find out which one is relevant, which one is irrelevant, which one is this group, which one is that group, we can easily able to find it out. So interpret large data set, that is group it. So bunch of data if we have, we can separate it, then we can easily able to find it out. These are the things we can easily able to group it, and then we can easily able to, these things are come this cluster or that cluster, we can easily able to identify it. And then unsupervised learning, so this is the way we are going to process it, the data. See, the same the classification supervised algorithm, the supervised learning process, we have algorithm and the processing, we can easily able to find it out the data. In the same unsupervised learning, see what we are going to do, the data we are unknown, the data we are unknown, so that's why we are going to interpret the data. That means no training data sets. Previously, trained data sets we are used in classification algorithm, and unsupervised learning we are not used trained data sets. So we are going to interpret the data, then we are going to provide the algorithm, then we are going to process the data, so then we can get the output. Okay, here we are going to two more process we are implemented in unsupervised learning process. See, this is for raw data. See here, various kind of images we have. That images is captured various objects. This is for the original unsupervised learning algorithm. See, we can fetch it out which one is suitable for us. See here, clustering involves a grouping set of similar data, and also it is useful for segmenting data into several groups. That means we are going to analyze different kind of data. That is, we are going to find it out the segments, and then dimensions. If we are segregated, the centralization, that is data centralizations, we are reduce it. Finally, we are concluded to cluster or more than to one cluster. So we are categorizing n number of clusters. See, we are finally concluded two only. So which one is this group or which one is that group? That kind of specifications we are going to specify it. This is for reinforcement learning, that is semi-supervised learning. See, this is for partially supervised, partially unsupervised. Partially supervised and partially unsupervised. See here, some data are meaningful and specified, very effective. At the same time, some data we are not have sufficient informations. No, that does not specify in label. See, in this for reinforcement learning. See, the reinforcement learning is input, and then see here environment and the agent is the cyclic process is happening. See which one algorithm is suitable. Previous one is unsupervised learning is we are finding out the clustering techniques, we use it. But here the data's reinforcement learning also not training data set. So what we are going to here, we are finding out the which one algorithm is best for this data, that is input data. So we can more than one time we can change the environment and the engine. So which one is sufficient, we can receive it. That means which one algorithm is sufficient algorithm, then we can better output results will be we are receive it. That is a semi-supervised algorithm. See, this is the image for reinforcement learning. See, the ball is going to capture the dog. See, the next one image is the same way capturing the image, that is ball is captured or image is captured to recover from the dog. See which one technique is we are going to implement, we can retrieve it. See, this is for robotic image. See the level of reward value, that is reinforcement values updating in the episode 1 and 2, 3, 4. See this is for categorization of specification in machine learning, supervised, unsupervised, and semi supervised learning. See, in the unsupervised, two things here we have used: clustering and dimensionality reduction. See, clustering is a targeted marketing and customer segmentation, and this is for example. See, recommended systems. Which one is we are going to implement? See, and then big data, meaningful compression, and structure discovery, future election. Those things are in dimensional reductions. See, these things we have in unsupervised learning. But classification and regression, see, diagnosing customer intention, image classification, identity, fraud deductions, and regression techniques also, advising popularity prediction, weather forecasting, market forecasting, estimate life expectations, population growth predictions. Those things are commanded to classification, that is supervised techniques. And the reinforcement does use robotic navigation, learning tools, skill acquisition, uh, game, and real-time decisions also in real-time. Reinforcement learning. See, these are the algorithms we used in a listed, but not more than a number of algorithm we are going to use in a machine learning algorithm. These are the families of machine learning algorithms. See, most of the most common and popular machine learning algorithm, Navy Bayes, K-means, support vector machine. K-means is unsupervised, and Navy Bayes and support vector machine is supervised, and then linear regression is supervised, logistic regression also supervised, and the ANN is reinforcement learning, and then decision tree, random forest, Navy Bayes, nearest neighbor also supervised, as well as classification and regression also applicable in decision tree and random forestry. So what it is going to, the benefit of the machine learning algorithm? See, the main reason is uh, reduce the data size, quality, diversity, and it will become effective. And also it include the accuracy, and then performance, and then processing time, and then passing the values, that is parameter values, and also more and more as benefit as machine learning algorithm we use, we can get most experienced data science the people are using in a machine learning algorithm, and it will perform best before experimenting with others algorithms also. See, just let's we are going to discuss the classification algorithm. See, the classification type, see, binary classification or a multi-class classifications. See, the binary classification will custom by a life insurance, that is yes or no, that is a 0 or 1 binary classification. The same multi-class classification is more than one value, so we are given democratic or republic or independent. So which party a person is going to vote for you? So we are going to specify which one, democratic or republic or independent, which one. So the classification type is a binary as well as a multi-class classification. See, the terminologies in classifications. So the algorithm, the classifier is mapping to the input data to a specific category, so we can easily able to find it out. See, the same thing as binary classification, that is a male or female. Previously I told customer buy a life insurance, yes or no, the same. So multi-class, multi-label. See, the classification task is sampling is mapped to set of target labels. That is, a new article can be about a sport, person or a location at the same place, or that thing is specified in multi-label classification. And in steps in classifications, so first thing is we are going to initialize the algorithm, that is which one process we are going to use, and then training the data set, that is we are use here the scikit is a Python technique is you are here using. So the Python also is more effective, and R also, MATLAB, Vega tool, various kind of tools are using to train the data sets, and then predict the output results. Predict the output results, which one is efficient, that thing is we have it, and then the results will be compared to other models. So this is for classification steps. See, in example, these things are we have natural language process, machine version, that is a phase detection, spam filtering, and in proteins functions finding, and in market segmentations. Those things are we are using in classification problems. And then linear regression also supervised learning technique. And linear regression is one the model is a scalar model, and it responds to one or more as a dependent variable. We can easily know to find that which one is relevant. We can dependent variable, independent variable, we can find it out in linear regression value. See which one is belong to this line that is exactly mapped in that values will be dependent or independent value. So that value will be, we can easily able to identify it. So the linear regression model is we are using. See the slope, we have find it out where does the intercept will occur, and the slope where it will be find it out. So the intercept is arise in that I think so 1 2, the position will be 0 and 1 2, the intercept is occurred in 2, the slope is we received in that particular place, that is dependent variable and independent variable we are calculated. That is a slope of the variable where it will be occurred, that particular place we are find it out. The linear regression is predicted the value in continuous way. So the classification is predicted values categorical. This kind of predicted value in linear regression is continuous values going on. It will going on. See, this is the value will be not it stopped. It will going on. Up and down will be the value may be vary in particular place. The same in classification, the predicted value is categorical, democratical, republican, and independent. So these things are we have categorized it. The linear regression, home price, weather, stock price, the values are going on continuously. See the regression is classification. Regression is what is the tomorrow temperature is going to be tomorrow. The prediction is approximately 84. The classification, it will be cool, cold or hot tomorrow. So the prediction is the temperature is 84 or here 150. The prediction is maybe hot, maybe cold. So the classification depends on the temperature here specified. The regression is find it out that sequence is going on. Okay, it not at stop. The prediction is temperature. So this is the graph. The sequences flow will be, the slope will be identified here. The linear regression, the predicted values, y lies in the same sequence. So the linear regression is the logistic regression. The linear regression, the values may be vary in that straight line. But in the logistic regression, maybe the value will be predicted value will be the limit range will going on the 0 or it may be the 1. K nearest neighbor algorithm. So the K nearest neighbor algorithm before KNN. So the value, new data value here, we have it two kind of categorizations. We have it, the cluster we have it. So category A and category B. The new data point is assigned in which one is near the calculation, the distance, equally distance formula. We use it. We are find it out which one the new data belong which category. The category may be here. The distance is very near in category A, but the distance is not the centroid value. We have find it out. We can category A and category B. We can find it out the centroid value, and then we assume that centroid value, the distance category A and B, which one is the minimal. That category will belong to that K nearest neighbor algorithm will update it. So the new data point. See the non-parametric. So identifying the equivalent distance calculation, we can identify it the category A or it may be a category B. So this is the algorithm procedure. Nearest neighbor, there is a Y is the vector outcome of the value, vector treatment status, and the matrix covariates. So we can calculate the mean of the value. We use the equivalent distance formula. We can get it. Next one is SVM. SVM also is a classification that is a supervised learning method, classification, regression, and outlier deductions. See, in the SVM have minimal and fall on the positive and negative edges values. That is a positive hyperplane and negative hyperplane. So maximum and minimum of the value, maximum and minimum, maximum margin hyperplane and maximum margin value we receive it. See, we are finding out optimal value for both maximum margin as well as in positive hyperplane as well as negative hyperplane. Which one is distance will be find out the clustered values. We are segregated in that SVM. The data belong to this specific region. That optimal hyperplane values, the distance we are finding out. We can use it that SVM. See, linear separably and not linearly separably. The two types of SVM we have. So here in the previous one is positive hyperplane as well as the negative hyperplane we have it. Maximum margin, the maximum margin hyperplane we are segregated two categorizations, that is optimal hyperplane value and then maximum marginized hyperplane value we have it. We are linearly specify in that first one category. Second one is not linearly separable. It was combine both values we have it. See, we are going to segregate it. We use the formula. We can find it out that positive as well as the negative hyperplane values based on that formula. We can get it the results values. See, it's an example for SVM. So cat and dog. So the values are labeled. Cat and dog labeled. The model is going to train and predict the values. It is we are providing the values a cat or it may be a dog. So output will become a cat. So we can receive it the output properly. The next one is the decision tree. The decision tree is it's like a binary tree like. So is a root node splitting at the terminal node. That is terminal node. We have finite values. We have it. For how many branches we have it, as many subtrees we are going to create it. So we can use the parent tree is here complete binary tree like that. See the root of the value A and the parent of terminal node B and C. That is a subnode. We have it. See like that. See a salary is the example. The salary is 50,000 as commute. More than 1 hour you spend. If it is S, decline the offer, or otherwise no offer free. Offer is free coffee, declined offer, S is to accept. This is the root and leaf. See, the declined offer is further, it is not expanded the leaf. Okay. See, the another example, a person is fit for some example, eat a lot of pizzas, S, age less than 30, S or no. So exercise is in the morning, fit or unfit. And then S or S is unfit, is no as a fit. See, S is fit and unfit. See, this for decision tree. And anybody is the Bayes theorem is classified particular field. The likelihood and unlikelihood informations we categorized in posterior probability of the class, that is the target and the predictors. The target and predictors is P of C is equal to predictor value, that is the prior probability, class prior probability is predictor probability divided by the prior probability. The posterior probability we are getting the answer. The classifications prior probability of the class, and in predictor values, that is attribute values, we are positive in that value. We can n number of values we have it, all the values will be executed. We can convert it in a frequency table. If it is yes or no, the weather is weather value, frequency, overcast and rainy, sunny, grand total. The average value we receive it, which one is effective value. So possibility is 0.29, 0.36, 0.36. That is maybe sunny or rainy. The possibility is it will based on the recall value. We can receive it the output of the value. And then finally, in machine learning techniques, we used various platforms that is and tools also used in uses is more and more. And not only in the machine learning process, all the sectors we are use it. Not in a specific place, in software industry, healthcare, automobile manufacturing, and entertainment, agriculture, every places we are going to use. And also the topmost companies, also software industries and social medias, and then marketing places, and then development companies also investing in machine learning environment. Thank you for your patient to hear the lecture. If you have any doubt, ask me. Thank you for the participant to giving me the opportunity to provide me for this daily lecture in SJP Jain College. That Nagajodi sir. Thank you, sir.
Thank you, sir. It's time to questionnaire session.
Okay, sir. Okay, ma'am.
Sir, there is a question to Mr. A.R. Anish. Please explain at least one algorithm.
Sir?
Please explain at least one algorithm.
One algorithm.
Yeah.
The k nearest neighbor algorithm.
Yeah.
In this algorithm, we have the parameter casual k means algorithm, k nearest neighbor algorithm, k, y, and w and the x. The four parameters we have, that is the four parameters inputs. The input is k is a number of nearest neighbors. That means nearest values in that cluster, and then y is the vector, that is the direction of the value, that is new values, outcome values, vector of the outcome values, that is a y. W is a vector with the treatment status. we are going to specify in that category A or category B. That is, we are specifying in W, and then X is a matrix covariate. So now the process, the input we are received, now the process will be started. So beginning, select the nearest neighbor for each observation, that is iterating the one by one. How many values we have in category A as well as category B. So observation I based on the covariates x-axis based one by one value we are iterated. So nearest value for the new one. Separate the k treated as w of I, that is vector with treated as treatment status wi is equal to 1, initially started as 1, and k untreated as wi is a 0. So two specification, treated as we are specified 1 as well as untreated as 0. So the nearest neighbor for each observation, so one by one the iterations we are going to do, the calculated mean of the y of k w is equal to 1 and y of k w equal to 0. That is treated value we are represented, that is nearest for that category A or not category B. So we are categorization is specify, calculate the mean of the value y of k w is equal to 1 and y of k w is equal to 0 and a flipped I. So the value will be move on the next category of flipped. If that means mean of y of k w is equal to 1 minus mean of y of k w equal to 0. So that means, see, we are the new identified data we are specified in category A. So the nearest value we are assume this w of I is equal to 1. The separated of k value is we are identified as 1, that is belong to category A. So this diagram I think so, sir. See, this is for category A and category B. The new data point is here. We have it. The distance value we are identified. So we are started in that x-axis based one by one. So first and then second and third and fourth, fifth, sixth, 7 and 8, 9. So the next one is we are moving on. See, this point is specified. The iteration is the distance become category A is exactly group it and as a KNN algorithms. Sir?
Sir, EGS for performance measure. EGS for performance measure.
Sir, sorry, sir.
EGS for performance measure. That is the one question. And another one, how machine learning can be used in higher education.
Higher education, in AI technique also we are going to use in nowadays also using AI is without teacher, as a teacher is in front of taking the class. All the things also now nowadays started, but not at our India started, but other countries also started in AI techniques is used in machine learning.
So thank you so much, sir. It's a very good, wonderful presentation today we had. And with these few words, I hand over the session to Ms. Asa Devi ma'am for further proceeding this session.
Okay, sir. Okay, sir.
Asa Devi ma'am.
Thank you, sir. Yes, sir. Thank you, sir. You brought us a valuable content to the participant. It was a really informative session to the students. Thank you so much, sir.
Thank you, ma'am. Thank you.
Last but not least, and now let me invite Mr. K. Kumaresan Assistant Professor, Department of Computer Science, to deliver the vote of thanks.
Okay, ma'am. Thank you, ma'am. So, good evening to all. I thank our Secretary, sir, management, principal, and vice principal for organizing this program. I extended my sincere thanks to our chief guest, Dr. P. Krishnamooorthy, sir, for the valuable information. Thank you, sir.
Thank
I
you, sir.
thank all the HODs and Professor Babu, HOD, PCA department, faculty members, and the students for active participations in this program. Thank you once again to everybody. Thank you. Thank you, sir. Thank you, ma'am.
Thank you, sir. Thank you. Thank you, sir.
Thank you, sir.
Thank you, ma'am. சார் லைவ் இது பண்ணிடலாம் சார். பாபு
Okay,
சார்,
sir.
பாபு சார் லைவ் இது பண்ணுங்க.